My name is Wang. I'm a PhD student from Leiden Observatory and Tsinghua University, supervised by Professor Navi and Zheng Kai. Today I'm going to talk about my project to uncovering the Type-2 quasar populations at high redshift. Oh, sorry. So unlike the previous talk on the Type-1 quasars, we know that Type-1 quasars are the most luminous targets in our universe, and we can find them up to very high redshift, above redshift 7. So this gives us a well-known Type-1 quasar luminosity function in different redshift beams shown in these black curves. But also there are many Type-2 quasars, or they are also called obscured quasars, because the dust obscuration, they only have very faint continuum and narrow emission lines. This makes them very hard to be found, especially at a high redshift. So before JWST, there are many surveys trying to find these Type-2 quasars, but they all stop at redshift around 2. So this leads to a very unresolved Type-2 quasar luminosity function at high redshift. Now with the launch of the JWST, we can find a large population of faint and obscured agents. They are also known as LRDs. So here is a plot produced by Ali Abizadi. We can see that the number density of LRDs is much higher than the previous UV bright quasars. So this result indicates that the obscuration at high redshift may be much higher than we expect. So we also need to know that does this case also happen in lower redshift, like redshift 2 to 4? I think the answer is yes. And the luminous Type-2 quasars must contribute to this population. So our motivation is trying to find this luminous Type-2 quasar at redshift 2 to 4 at the bright end. We choose this luminosity and redshift because they are easy to get a spectra even from ground base. And at the bright end, we know the sample is clean. We can easily argue that they are AGN dominated. So according to the current knowledge of their SEDs, we designed the optical-based selection and IR-based selection using deadly survey and WISE. So we choose the most bright candidates and put an optical non-detection or red color requirements. So here is an example of our candidates. You can see that there is no detection in Daisy and Pan-STAR, but there is a very bright in YSW4. And then we get the spectra of 49 of these targets, and we successfully identify 41 new Type-2 quasars. Unlike the previous survey, this time we find the most of them to be redshift above 2. So here are some preliminary spectral results. I just want to give the idea that we have a very diverse spectra. So the spectra from Keck, blue, red, and the Gemini genus. So the red one is kind of LRD-like spectra. We can only see the broad H-alpha emission lines and the narrow Lyman emission lines, and then nothing else. And also we have, in many targets, we also detect the very strong but narrow UV emission lines. So after get the spectra of these targets, we produce the composite photometry and conduct the SED fitting for both individual and stacking results. So I think the results here is that we find that the rest of the UV light can be fitted assuming a 100% scatter light by the accretion disk. And also our target have a very hot dust torus model here. This gives our target a very high bolometric luminosity. And we also try to fit this target without the AGN component, but the resulting star formation rate is too crazy. So we can know that our target is definitely AGN dominated. So lastly, we compare our results to JWST LRDs and discuss whether the LRD can have hot dust. So these blue dots and the black lines are our composite photometry and final SEDs, and the red dots and the orange lines are the LRD SED from Atkins. So I think the first thing is that we find a very similarity in our rest UV lights because they can both fit by the scatter lights. And in the hot dust part, I plot two hot dust torus template here with the same bolometric luminosity of the LRDs. But because of the uncertainty of the elbows, they have a shadow region here, and also the containments of this sample can bias the near IR measurement here. So I think for now, from this sample, we cannot rule out the possibility that the LRDs may still have hot dust. And considering the similarity in the rest UV and the possibility that they have hot dust, so maybe some LRDs with hot dust could just be the very faint but highly Type-2 quasars. And in the future, we will update this selection and composite photometry to Euclid and JWST to find more hazy type 2 quasars to further understand the obscured fraction and the nature of LRDs. That's all. Thank you.